Betelgeuse, the enormous red supergiant, the closest giant to Earth, has demonstrated a significant decrease in brightness in recent years, sparking a wide range of worldwide reactions. Some hypotheses suggest that this fading may indicate the approach of a supernova, a catastrophic explosion that has people worried. Public and scientific communities alike are focused on this major Orion constellation star. Betelgeuse has regained some of its previous brilliance that had diminished, but it seems to be entering a phase of reduced activity. Currently, experts are considering the future of Betelgeuse and whether its final explosion could result in any impact on Earth. Orion, one of the most iconic constellations in the sky, is well recognized for its two main stars, Rigel and Betelgeuse. The latter, also referred to as Alpha Orionis, is the most luminous star in Orion. Observations made by NASA's Hubble Space Telescope and various other observatories revealed that Betelgeuse underwent an extraordinary mass ejection in 2019, an occurrence never recorded in any star of its kind. Although coronal mass ejections, CMEs, are relatively common with our Sun, this particular outburst from Betelgeuse was one of a kind and has sparked astronomers' intense fascination. This massive explosion of material expelled by the star was 400 billion times greater than the typical CME observed in stars similar to ours, briefly covering up some of its light and leading to its unusual dimming. Estimates of the distance between Betelgeuse and Earth vary, with some placing it as far as 724 light-years away. Calculating the distance to the red supergiant Betelgeuse and other giants is difficult because of their great distance and unusual traits. Betelgeuse is one of the brightest stars visible from Earth, shining approximately 100,000 times the dazzling brightness of our Sun. This intense luminosity comes at a cost. Betelgeuse is exerting itself vigorously, rapidly burning through its fuel and accelerating toward its inevitable end. The star will eventually exhaust its fuel supply, collapsing under its own gravity and increasing the risk of a supernova, a violent explosion that might leave behind either a neutron star or a black hole. Does Betelgeuse pose a threat to Earth? If the star were to explode in a supernova, its outburst could have catastrophic consequences for Earth. Supernovae are capable of emitting light so bright that it can rival an entire galaxy. Even though Betelgeuse is relatively distant, such an explosion would be difficult to ignore. The last observed supernova in our galaxy was in the year 1604, and the most recent, in 1987, occurred within the Large Magellanic Cloud, at a distance of 169,000 light-years. The potential for harm from a nearby supernova remains an intriguing and concerning possibility. If such an event were to unfold within our galaxy, it could have significant effects on Earth. Supernovae, though spectacular, are much less powerful than gamma-ray bursts, which have entirely different dimensions. While supernovae have the potential to obliterate biospheres and blanket planets with lethal radiation, their ability to remove ozone from a planet's atmosphere is particularly problematic. The ozone layer, if damaged or destroyed, exposes the planet to harmful ultraviolet light that could cause a mass extinction event. The initial burst of radiation from a supernova is threatening, but a more subtle threat is posed by cosmic rays that arrive thousands of years later, capable of further damaging the planet's surface and possibly preventing the recovery of life. Records from the past provide evidence of previous supernovae. For example, traces of iron-60, a radioactive isotope created during supernova explosions, have been detected in Earth's oceans and lunar regolith, implying that Earth might have been affected by supernovae a few million years ago. Despite astronomers ruling out an immediate supernova danger, they have identified a second potential risk. Certain types of supernova emit radiation that can travel great distances and cause harm to planets like Earth. When a star nearing the end of its life is surrounded by a substantial amount of material, a specific type of supernova may occur. The shock wave from the initial explosion strikes the disk surrounding it, causing the release of a large quantity of high-energy X-ray radiation. This radiation has the potential to deplete a planet's ozone layer by as much as 50%, which could cause an extinction event within a range of 150 light-years. Fortunately, no such X-ray emitting supernovae are currently known to be sufficiently close to Earth to pose a direct threat. These findings have caused astronomers to reconsider the boundaries of the galactic habitable zone, the region within galaxies where life is likely to exist. Star formation in the outer regions of a galaxy is too low to produce the required components for rocky planets, while the inner regions, where stars are born and die quickly, are hazardous due to frequent supernovae radiating harmful radiation into their surroundings. According to research, the inner boundary of the galactic habitable zone may be farther from the center of the galaxy than previously thought. How would a supernova like Betelgeuse appear from Earth? While the biosphere on Earth would most likely remain intact, the spectacle would certainly be impossible to miss. According to astronomers Goldberg and others, the explosion caused by Betelgeuse would result in a brightness roughly equal to that of the full moon, visible for a few months. This brightness would be visible even in the middle of the day, and would cast shadows during the night. For several years after, the supernova's remnants would remain visible to the naked eye. Although Betelgeuse's supernova would be an intriguing occurrence, its repercussions cannot be denied. The global fascination with such a phenomenon would be undeniable, but the implications for Earth's future environment remain uncertain. As scientists continue to monitor this red supergiant, we can only watch, hoping that any threat, if it exists, is far off. The eventual explosion of Betelgeuse as a supernova would be a stunning sight, but not without significant consequences. The enormous burst of light from such an event would likely be the second brightest object in our sky after the sun, shining, with an intensity so great that it could easily surpass the moon in appearance. It would be visible to the naked eye during daylight hours, casting visible shadows in the darkest of nights. This spectacle would captivate worldwide observers. Despite its blinding light, it's important to note that supernova-emitted visible light represents only a small portion of the total energy produced. The more pressing concern is the high-energy radiation released, typically in the form of gamma rays and X-rays. These forms of radiation pose a grave threat and have the capacity to deplete Earth's ozone layer, a shield of protection that prevents harmful ultraviolet rays from reaching the surface. Without this layer, life on Earth would be exposed to dangerous radiation levels, increasing the risk of a mass extinction event. The aftermath of the explosion would not end with the instantaneous surge of energy. Cosmic rays, subatomic particles accelerated to nearly the speed of light, would follow, continuing the devastation by bombarding the planet for hundreds of thousands of years. These particles have the power to penetrate Earth's atmosphere, further deteriorating the ozone layer and potentially altering the course of life on the planet for millions of years. Despite the fact that we haven't seen a supernova of this magnitude in our own galaxy for centuries, evidence suggests that such events have taken place in the past. Traces of iron-60, a radioactive isotope produced during supernovae, have been discovered in samples of lunar soil and sediment layers, indicating the possibility of Earth being exposed to debris from a nearby star explosion within the past few million years. Although no immediate dangers from supernovae are predicted, the knowledge of their potential dangers has prompted astronomers to keep a close watch on stars in the area, such as Betelgeuse. Another has also been discovered by researchers, a kind of supernova that could cause even greater danger. In some instances, a star's final blast could be surrounded by a massive disk of gas and dust. When the collision of the explosion's shock wave with this material occurs, it generates a powerful burst of X-ray radiation traveling vast distances. This X-ray emission can deplete a planet's ozone layer, substantially raising the likelihood of a catastrophic extinction event. These types of supernovae, while not common, could pose a serious danger if one were to occur within the next few hundred light years. Awareness of this additional danger has caused astronomers to revise their understanding of the habitable zone within our galaxy. Prior researchers assumed that the habitable region of the galaxy spread out further away from the center of the galaxy. However, new evidence indicates that the inner parts of stars, where they are born and die quickly, may be far riskier than previously thought. The frequent supernovae in these areas could bombard nearby planets with radiation, making them inhospitable for life. This has led researchers to believe that the galactic's outer limits habitable zone may extend farther than originally conceived. Looking ahead, what would a supernova like Betelgeuse look like? Its juices appear to be from Earth, but the explosion itself would have little to no direct impact. The event's impact on Earth's biosphere would still be a spectacular sight. According to researchers Goldberg and others, the supernova would shine brightly with a brightness comparable to half of the moon's, visible for several months. During its peak, it would be so intense that it could be seen during the daytime, even in the dead of night, casting long shadows. They diminish as the supernova's remnants would remain visible to the naked eye for a number of years, making it an unforgettable celestial event. While the explosion of Betelgeuse as a spectacle would enthrall audiences all over the world, its long-term effects on the planet remain uncertain. The supernova's radiation would still be a threat to the world, particularly with the possibility of the ozone layer being severely damaged. Although life on Earth may survive the event itself, the effects of prolonged contact with harmful radiation could alter the planet's ecosystems, resulting in significant changes to the atmosphere for thousands or even millions of years. Over time, the potential for a nearby supernova to cause significant harm to Earth remains a subject of ongoing investigation and concern. While the impending explosion of Betelgeuse may not result in the complete destruction of Earth's biosphere, the radiation emitted would still present an incredibly powerful and dangerous force. The initial burst of energy from the supernova would likely include a combination of gamma rays and X-rays, which have the ability to deplete the ozone layer, which safeguards life on Earth from the harmful UV rays of the sun's radiation. The absence of this protective shield leaves the planet vulnerable to risky radiation that could have grave repercussions for life, including potential extinction events. Following this, cosmic rays from the supernova's explosion, extremely active particles traveling at nearly the speed of light, would arrive. These rays have the potential to pass through the atmosphere and continue their harmful effects for hundreds of thousands of years. While the immediate blast from the supernova might be devastating, it is the long-lasting effects of these cosmic rays that could prove to be even more destructive over time. They would continue to disrupt Earth's environment, preventing the recovery of its ecosystems and possibly causing prolonged periods of lifelong instability. Iron-60, a radioactive isotope created by supernovae, has been found in the oceans of Earth and in lunar soil samples. This discovery implies that Earth has been subjected to the traces of an explosion caused by a supernova in the not-so-distant past, possibly within the last few million years. Although astronomers currently do not see any supernova at a dangerous distance, Iron-60's detection from Earth raises questions about the potential dangers from an approaching star explosion. These findings highlight the need to keep a close eye on the nearby stars within our galaxy, specifically those in the late stages of their life cycles, such as Betelgeuse. In addition to the threat posed by traditional supernovae, astronomers have also discovered a potential risk. A specific type of supernova occurs when a dying star is surrounded by a large disk of gas and dust. As a result of the supernova explosion's shock wave, this shock wave collides with the surrounding disk, producing a tremendous amount of X-ray radiation. This radiation can travel vast distances and has the capacity to substantially reduce the ozone layer of any planet within a certain radius. A planet exposed to such radiation could confront dire consequences, such as the triggering of an extinction event. Fortunately, there are no stars showing this type of X-ray supernova that are recognized as located near Earth. However, the discovery caused by this brand new type of supernova has led astronomers to rethink the boundaries of the galactic habitable zone, the region where it is most likely that life exists. In the past, scientists believed that the galactic habitable zone extended farther away from the galaxy's center. As we proceed with our study of Betelgeuse and additional stars nearing the end of their life cycles, astronomers concentrate on understanding how various supernovae could affect Earth's life. While the immediate threat posed by supernovae from distant stars may not be catastrophic, the long-term consequences of the radiation they emit are still a cause for concern. The excessive energy radiation that comes from a supernova, especially gamma rays and X-rays, can have far-reaching effects even if the star is far from Earth. It is this persistent radiation that can have long-term effects on Earth's biosphere. An aspect that is receiving more attention is the potential for future supernovae to alter the makeup of Earth's atmosphere. Supernovae are capable of sending shock waves and radiation through space at astonishing speeds, and if these waves reach Earth, they might spread disruptions. For example, shock waves from a nearby explosion could possibly eliminate much of Earth's atmosphere, affecting how we breathe and altering global weather patterns. Additionally, the radiation emitted could increase the incidence of mutations in organisms, potentially leading to evolutionary shifts or the extinction of a number of species. Another important part of research entails the creation of nearby stars and the space around them. As stars like Betelgeuse approach the end of their lives, they begin to shed material that travels through space. This material, which may include heavier gas and dust elements, could play a significant role in how a supernova unfolds. The interaction between the advancing material around a dying star and the shock wave from the supernova could influence the type and amount of radiation released. This interaction could, in turn, affect how much damage a supernova strikes any planet in range. Despite the absence of supernovae currently anticipated to bring about an immediate threat to the planet, current observations will continue to monitor the development of stars like Betelgeuse. As our ability to detect and analyze cosmic events improves, so too does our understanding of how these explosions of stars might shape our planet's future. Scientists are optimistic that discoveries associated with supernovae will lessen the risks and enhance our ability to predict their effects on the natural environment of Earth. By keeping an eye on the sky and studying the life cycles of stars, we can prepare for the unexpected and ensure that we're better equipped to deal with the issues that arise from these enormous planetary events.